Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. We are from group C7 for our assignment 1 in course Smn3043. These are our group members. So, this video will explain 2 questions with 2 sub-questions for every question. Enjoy! Question number 1. A steel bar weighing 2 pounds is dropped from a height of 3,000 feet with no velocity. As it falls, the ball encounters air resistance numerically equal to V over 8 pounds, where V denotes the velocity of the ball in feet per second. Assuming gravity is equal to 32 feet per second square, first, how can we find limiting velocity for the ball?
First, how can we find the limiting velocity for the ball? So based on the question, we know that weight W is equal to 2lb, gravity is 32 feet per second square, and air resistance is V over 8 in pounds. We also know that the formula includes air resistance is M times dV over dt equal to mg minus kV. Then we need to modify this formula and we will get dV over dt plus kV over m equal to g. So the formula for weight is equal to mass times gravity. So based on this formula, we can get mass, which is equal to 1 over 16. And for kV here, we know that air resistance is V over 8 in pounds. So kV will be equal to V over 8. When we get the value for kV and also m, we can plug in into this formula. And then we will get dV over dt plus 2V equal to 32. Again, this is a linear first order differential equation, so we need to solve it by using integrating factor. So we know that this equation here is in standard form, which is this form. So first we need to find a v of t, which is equal to exponent to the power of integral of px dx. So equation here, we know that px is 2, so we can write it as exponent to the power of integral of 2 dt, and then we will get exponent to the power of 2t. Next, we need to multiply this equation by Vt, so we will get exponent to the power of 2t times dV over dt plus 2 exponent to the power of 2t times V equal to 32 times exponent to the power of 2t. So when we get this equation here, we know that the left hand side is the derivative of the product of Vt and also V, so we can write it as d over dt, exponent to the power of 2t times v equal to 32 times exponent to the power of 2t. Next, we need to integrate both sides of this equation with respect to t, and we will get exponent to the power of 2t times v equal to 16 times exponent to the power of 2t plus c. And then we need to divide all of the equation with exponent to the power of 2t, and we will get v of t equal to 16 plus c times exponent to the power of negative 2t. Next, we need to find a c constant here. So we know that the initial velocity is 0, so v of 0 is equal to 0, and we get 16 plus c times exponent to the power of negative 2 times 0 equal to 0. So constant c is equal to negative 16. So we get the v of t equal to 16 minus 16 times exponent to the power of negative 2t. So if we want to find the limited velocity, so we need to find the limit of this function here as t approaches infinity. So we can write it as limit of 16 minus 16 times exponent to the power of negative 2t as t approaches infinity. So the second term here, we need to write it as a fraction. So we get the second term here will be approaches 0 because the denominator is increasing without bound. So the answer is 16. Then the limited velocity is 16 feet per second square. That's all for me. I hope you can understand my explanation. Thank you.
Next, how about the time required for the ball to hit the ground?
Okay, we can use the differential equation that we got to find the time required for the ball to hit the ground. First thing first, the differential equation that we got is Vt is equal to negative 16 exponent to the power of negative 2t plus 16, which is Vt is represent velocity and St represent the displacement. We can get the St when we integrate the Vt. Next, we integrate both sides of the equation. To integrate this equation, we also use U substitution method by let U equal to negative 2t. After we solve it, we get st is equal to 8 exponent to the power of negative 2t plus 16t plus c1. The next step is we must find the constant at s equal to 0 and t equal to 0. Then we substitute the value in the equation. After we solve it, we get c1 equal to negative 8. Then st is equal to 8 exponent to the power of negative 2t plus 16t minus 8. From the information given, we know that st is equal to 3000. Then we substitute the value in the equation and calculate. So we get 376 is equal to exponent to the power of negative 2t plus 2t. This equation cannot be solved explicitly for t. Then we approximate the value by substituting different values of t. But we note that for any large value of t, the negative exponential term will be negligible. Finally, a good approximation is obtained when 2t is equal to 376, then we get t is equal to 188 seconds. Therefore, the time required for the ball to hit the ground is 188 seconds. I hope you can understand about the solution just now. Thank you.
Next, we are moving to question number 2. A 50-gallon tank initially contains 10 gallons of fresh water. At t equal to 0, a brine solution containing 1 pound of salt per gallon is poured into the tank at the rate of 4 gallons per minute, while the well-stirred mixture leaves the tank at the rate of 2 gallons per minute. First, how we can find the amount of time required for overflow to occur.
Alright, let's find the answer for 2A. First, we let E is input rate of brine, F is output rate of brine, V naught is initial volume, and T is time. Next, the volume of brine in the tank at any time t is given as V is equal to V naught plus open bracket E minus F close bracket T. So, from the question, we know E is equal to 4 gal per minute, F equal to 2 gal per minute, V naught equal to 10 gal, and V equal to 50 gal. Then, we can substitute into the formula and we get 10 plus 2t. Lastly, we require t when 10 plus 2t equal to 50. Then t equal to 20 minutes. Hence, the amount of time required for overflow to occur is 20 minutes. I hope you can understand. Thank you.
Next, what is the amount of salt in the tank at a moment of overflow?
So, for the answer to B, there are 6 steps to solve this problem. The first step is we should let S equal to amount of salt in time at any time. The second step is we should find the rate change of S, where the rate change of S equal to input rate of salt minus output rate of salt. The third step is we need to find the input and output rate of salt. This is the formula, input and output the rate of salt. After we solve it, the input rate of salt is 4 pounds per minute. Meanwhile, the output rate of salt is S divided with 5 plus T. After we get the input and output rate of salt, we are going to substitute back into the rate change of S. After that, we multiply both sides with the integrating factor, which is 5 plus t. Then, we simplify it. The fourth step is, we need to integrate both sides of the equation and we get s equal to 2t squared plus 20t plus c divided with 5 plus t. The fifth step is we need to find the equation of s. When t is 0, the constant is 0. So, we will get s equal to 2t squared plus 20t divided with 5 plus t. The last step is we substitute t equal to 20, which we get in 2a. We solve it and we will get the answer, which is s equal to 48 pounds. Easy, right? Do you get it?
These are extra exercises that you can try to increase your understanding. First question about falling bodies and air resistance. Second question about draining tank. We also provide the answers so you can check you'll get the correct answer or not. That's all from us. We hope this video will help you. Thank you. Bye.